All right, we're gonna go ahead and start with what we're doing today. We're analyzing graphs and graphing two stories. So before we've been graphing one story, like we listen to the story and then we put it on one graph. Today we're gonna really look at listening to two stories and putting it on the same graph. All right, so our learning intention states, I will learn the meaning of point of intersection when two lines intersect between two graphs and find specific points in a graph. So I want to be able to look at a graph and analyze and read it. To be successful at that, I will be successful when I can graph two stories on the same graph, label the axes appropriately, and then analyze it, the graphs. And then we'll go through some of these activities. I have 3 activities down here that we'll do. And then I also have some other stuff that we'll get through as well. So to start out, we're going to listen to this video. She explains it very well. So we're going to listen to this video, and then I'll pull up another example for us to look at in a little bit. So to start out, let's get this popping.
This is the example. Consider the story. Duke starts at the base of a ramp and walks up it at a constant rate. His elevation increases by 3 feet every second.
I'm going to put a pause to that real fast, because if you do not have paper and pencil out, you're sadly mistaken. You need a paper and a pencil.
Just as Duke starts walking up the ramp, Shirley starts at the top of that same 25-foot high ramp and begins to walk down the ramp at a constant rate. Her elevation decreases 2 feet every second. All right, so question 5 says, sketch 2 graphs on the same set of elevation versus time axes to represent Duke's and Shirley's motions. Well, when I got thinking about this, I thought, wow, I'd have to do a lot of steps in order to sketch these 2 graphs. So I have some guiding questions to help us do that. I'm going to switch to my next page. You don't have these questions, but it's just going to help us to be able to sketch these 2 graphs. So we're asked to sketch 2 graphs on the same set of elevation versus time axes. All right, so let's create those axes.
Okay, so I'm going to pause because I want to put it in the chat real fast. Put in the chat, what do you think we're going to label our axes, all right? What do you think, or what, any recommendations of what we should label our axes? Go ahead and put that in the chat real fast, and I'll continue.
What should we label them? Well, yeah, are you thinking that, Mrs. McGinnis, they said it's the same set of elevation versus time axes. You're right. And haven't we been doing that in a lot of the lessons previously, right? We did that in lesson 1, and we also did that in lesson 2. We had those elevation versus time. All right, so what do you think your axes would look like? All right, well, this is what I came up with. I had that elevation versus time graph, where elevation is my vertical axis and time in seconds is my horizontal axis. So I have those feet and that second. Okay, I also had to scale it a little bit on my vertical axis. So I went up by every 3. I marked it every 6 on every other line. See here, 6. I skipped a line, 12, 18, and so on, just so it didn't look all cramped up. Okay, here's another question. What is Duke's initial elevation?
All right, could you guys go ahead and put some of that in your chat as well? Okay, initial elevation. Yep, because up here it says Duke starts at the base of the ramp. So where is he gonna start? The initial elevation. Put that in point intercept notation for me so I could see the X, the Y value. Where is he gonna start? Go ahead and put that in the chat and I'll see it. I'm gonna continue the video.
Well, it says Duke starts at the base of the ramp. Well, if he starts at the base, that would mean that he's starting at 0 feet. And I'm going to give myself a point of reference. He would start at that origin, or that 0, 0. All right, let's keep thinking about Duke for a second. At what rate is Duke traveling? What do we know about his change in elevation? And what information does that provide for Duke's graph? All right, got a lot going on here. So let's go back to the story. At what rate is Duke traveling? All right, well, his elevation increases by 3 feet every second. All right, so that means that we have a 3 foot per second rate. And the change in Duke's elevation is positive. The elevation is increasing, right? His elevation, he's moving up. It's an increasing function. And he's traveling 3 feet every 1 second. Okay. So with this information, can we graph a line for Duke? I think that we can. Why don't you give it a try, and then we'll look at mine. Are you thinking that the graph should look something like this? Well, let's think about it for a minute. We had Duke's initial elevation at 0, 0, or 0 feet, and he's traveling 3 feet every second. So he's moving, in 1 second, he's moving 3 feet. In 2 seconds, he's moving 6 feet. In 3 seconds, he's moving 9 feet.
I just want us to look again and see how she's getting this graph, all right? It said 3 feet every second. So for every second you go over on the line, it needs to be going up 3 feet. So then you end up getting your points for each, and then you just draw your line. And that's why it's constant. This is a linear graph, and it's constant. Because for every second, it goes to 3 feet, all right?
And so on. So his line would look like this. Great job. Let's think about Shirley now. So we're going to use the same line of questioning with Shirley. What is Shirley's initial elevation? Well, right here it states that Shirley starts at the top of the same 25-foot high ramp. So she's starting at 25 feet. And that point would be 0.25 because her initial amount. All right, so she's starting at 25. So on the y-axis,
could you explain to me how she got 0.25? Because she's starting at 0. Duke's was 0, 0, which is the origin. But what does the 0 represent, and what does the 25 represent? Could you go ahead and put that in the chat?
We would have to mark a point at 25 with time 0. All right. At what rate is Shirley traveling? What do we know about her change in elevation? What information does that provide for Shirley's graph? Well, it says that her elevation decreases 2 feet every second. So she's moving 2 feet every second. And the change in Shirley's elevation is negative. Why? Because her elevation is decreasing. So she's moving negative 2 feet per second. Now, does that mean she's actually moving back? No, or in a different direction, but she's moving down, right? So she's moving negative 2 feet every second. All right. So with this information, can we graph a line for Shirley? Let's do the same thing again. You give it a try. And when you're ready, come on back and let's look at the graph.
Right, so I want us to look at this. So Duke started down at the bottom. Where do we think on the y-axis is Shirley going to start? Is she going to start at the top or at the bottom of the y-axis? I'm going to put that in the chat and then I'll continue the video.
Yeah. Did you get a graph that looks like this? Yeah, I left Duke's line on here, right? And now Shirley starts at 25 and she's moving down 2 feet every second. Wow, it looks like there's an intersection point. I wonder what that intersection point is. Are you thinking that the intersection point is 5:15?
Okay, so 5:15, all you do is match up the points. You put the x value first, and then the y value, so 5:15. In the chat, though, I want you to explain to me, what does the 5 represent, and how does that relate to the 15? What are they saying? When I tell you that the intersection point is between Duke and Shirley is 5:15, what are they saying? because one's going down the ramp and one's going up, but they intersect at 5:15. 5:15 mean. Put that in the chat, and I'll continue to play this video. If my thingy, okay. Yep.
I think that you're correct. So number 6 asks just that. What are the coordinates of the point of intersection of the two graphs? At what time do Duke and Shirley pass each other? So we just found that intersection point, didn't we? Yeah, we said that it was 5:15. Well, wait a minute. So then what does that tell us about the time that Duke and Shirley pass each other? Are you thinking that Duke and Shirley will pass each other on the ramp at an elevation of 15 feet after 5 seconds? I think that you're correct. I think that they both spent 5 seconds and they would be on the ramp at 15 feet. Shirley coming down the ramp and Duke going up the ramp. Let's take a look at number 7. Ooh, number 7 says,
and we're going to stop it right there for, all right, there's another example that I want us to look at so that we can look at it from a different standpoint, all right? With this example, it's coming from a business standpoint. So say, for instance, you own a business, all right? And we're trying to, and I've plotted this graph on here where the bluish purple line represents the revenue, and then the red line represents the total cost whenever we're making something. So say, for instance, we're making PS4s, all right? So the total red line represents how much it's going to cost us to produce that many and sell them, all right? But then now we have to look at the axes. The x-axis, it was labeled units produced and sold. So that's talking about the number of PS4s that we're going to make and sell. And then the y-axis is talking about dollars. So it's really looking at how much money are we getting over time. The purple line is the revenue. Did anyone, let me go look in the chat. Did someone tell me what revenue means? And then the red line is the total cost. So we plotted 2 lines and they intersect at one point. All right, so we could really look at this graph and say, oh my gosh, what is happening? All right, so with this graph, revenue, when we're talking about revenue, it talks about the amount of money you're getting back. And it includes everything, all right? So if I'm selling 100 PS4s, whatever money I get back, that's my revenue. If I sold 600, that's my revenue. It talks about everything. Profit, expenses, because you know sometimes you have to spend money to make something because you have to pay your workers and everything. So that comes under expenses. And then once you've made that money and you sell it, you're going to make a profit. So revenue has the profit and the expenses all together. All right. So no, the total cost is only talking about the expenses. The total cost has nothing to do with the profit. All right. Total cost is how much it is to make the PS4. The revenue is how much it is to make the PS4 plus how much you make from selling the PS4. So I had a comment in the chat that says, so with the total cost being 8,000, so up here, the revenue is 12,000. So the company made $4,000 profit. Let's look at that real quick. So right here, it's saying, let's look at this point on the graph. If you follow my mouse, at this point on the graph on the revenue line, it's saying whenever I made and sold 200 PS4s, the total amount I got back was 2,000, but that includes the expenses and the profit. All right. But in order to really get it, I had to come up here and spend about $5,000 to make it. This point right here, this is where I break even. So whenever people say break even, can someone put in the chat what they know about what breaking even is? Have you ever heard someone say they broke even? So to explain it, I'm going to see the comments as they come in the chat. So to explain break even, it's more so of a thing where if I bought something for $2 and I'm selling it back for $4, over time I will be making back the same money that I spent. Or if I spent $2 and I sold it for $2, then I broke even. I didn't make any money and I didn't lose any money. So at this point right here, it's saying that it broke even. All right. This is just an introductory to something like this for looking at. So basically the original price, we're back to where we started. But the moment the revenue gets higher than the total cost, this whole part right here, we're making money. Because I'm starting to get more money in than what I'm spending. The red is what I'm spending for the product. The bluish purple is what I'm getting. So the moment my purple goes over the red is the moment I start making money. All right. But that's that video, and I'm gonna stop